Okay, well, how cool is that? So all of the lights work on the front, the microcontroller works. This is the 12 volt input being dropped to 5 volts. So everything that you see that's flashing is 5 volts. And then the microcontroller itself is 5 volts. Boy, check that out. Look at those unplugged wall warts. We've got 3 left. We're looking at these are all 12 volt now. So one is the bench power supply. Another is the coin insert buttons and the drink holder. And the other is the LCD driver. There's going to be a 4th one for the LCD marquee. So I'm going to have to come up with a power supply. Really leaning towards using terminal blocks, actually. Should be pretty easy way to dump 12 volts on everything and split it out, as long as the amperage matches and can handle it. But let's look at the back. Let's see how the back is doing. Okay, so I'm wearing a headlamp, and that is the bench power supply, 12 volts, and we're looking at about 1 amp, so that's pretty cool. It's at, let's see, 0.2 is the lowest I've seen, 0.93 is the highest I've seen, so 820 milliamps to so 939, so let's say 940. So 820 milliamps to 940 milliamps. Oh boy, all right, let's see. Let me kick off the lamp for a second. Okay, so this is where the bench power supply right here is feeding in 12 volts. And let's see, what are we looking at? 4.97 volts is our output. It's a little bit higher. Interesting to see it actually kind of dropping with some of the demand. We're still within range, so that's okay. Our amperage is also within range. I do expect to see 2.5 amps from the lights if I turned every single one on. I'd expect to see approximately that value. And then the Raspberry Pi Foundation, they recommend 3 amps for input. So we're looking at about 5.5 amps for what's on our output right here. And I have it set up to 6. Left a little bit of room for error. So 5 volts, 6 amps. It's kind of a value to hit, by the way. Different day's discussion, but it's been a little bit of a trick to find stuff that's rated for that much current at that voltage coming through. Oh, let's see, what do we have? Okay, so back to the headlamp. So we are looking at 5 volt right there, from there. And then to the lights, all up in there, those are 5 volt. And you can see the wire going all the way into there. So there. And then this right here that I'm touching is 12 volt, and 12 volt to the cup holders, and then to the coin insert buttons that you can see right here. And then this is my dumb trick with the Linux kernel, where I'm sitting there feeding these coin insert buttons and grabbing onto the GPIO of the microcontroller and simulating 5, 6, 7, and 8 being pressed when these hardware interrupts occur. Let's see, last but not least. Oh yes, 12 volt right there. Whoops, sorry, let me try other hand. 12 volt right there. And then there's gonna be another 12 volt that is going to run to the LCD marquee on up there. So total of 4 12 volt supplies. So let's count them out. There's 1, there's 2 right there. There's 3 up at the marquee, and then there's 4 right here. And that is how I'm going to then dump it all into a single 12 volt wire. Let's see, since we're using about an amp right now, and that's at, I just saw 2 amps on here. So let's do some fuzzy math. If we're gonna max out, we're gonna say 6, so we'll say 3. So I'm gonna say 3 right here. I'd have to go look at reread my blog article. That's actually, a lot of the blog articles I write is usually just notes, kind of geared for myself, that's hashed out so others can kind of follow along, which is why it takes me so long to actually write anything, since I spend way too much time trying to make it legible. But if I was just kind of randomly guessing right now, I'd say at the end of the day, we're going to be at 12 volts and 5 amps when everything is wired up together. I'm gonna have to reflect back on this video and see how close I am. So I'll say, just totally spitballing, 12 volt, 5 amp, maybe 6 amp. And that's it for now. That's one step closer to a single 12 volt wire that's running everything.